Hey everyone, welcome back. In this video we're going to be talking about, once again, it'll be a review of some of the stuff that we've done before, so this video isn't really going to have anything new, but just the same way that the last video had sort of like a step-by-step method for how to solve algebra problems with one variable, this video is going to be basically the same thing, but with two variables. So what I've done is so the way I'm thinking of going about this is we'll go through the sort of step-by-step method of how to solve an algebra problem with two variables. But what I haven't done is I haven't made a word problem example for us to do after that. And the reason for that is I'm thinking for your test, I might give you a word problem for one variable, but I'll keep it to just the numbers for two variables so that you don't have to worry about doing word problems in the ones with two variables, because that means you need to create both equations yourself, and that's just a little bit mean, so I'm not going to do that to you guys. So what we'll do is we'll go through the step-by-step process, and then we will just do two numerical problems, so like ones where I just give you the equations, and then we'll just do those two and we'll call it a day there. So this is a review of working with two variables. All right, so once again I'm going to try and be careful with that glare. Hopefully it doesn't get in the way too much, but yeah, I'm going to try and keep it off the board, because otherwise, yeah, if I put it there, you can't really see anything. So, yeah, working with two variables. So, once again, leave a little bit of extra space at the top for like a step 0. We'll throw in the step 0 right now, even though you won't really need to worry about this step 0 on the test. So, the step 0 is create your two equations. Based on the information given. So what I mean by this is if I was to give you a word problem based on the information given. Alright, so create two equations based on the information given. So that means if I gave you a word problem, I'd have to give you enough information that you could look at the question, read the sentences, and construct two different mathematical equations that you could then use to solve the rest of the problem. Now, because we're just getting used to the stuff with variables and getting used to solving them and solving word problems, we're not going to have to actually worry about this in the remainder of the unit. I'm not going to give you any word problems that involve two variables. It's certainly not something that'll be on the test. We might do some more of that in another review video, but it's not going to be something that I'm going to make you do on the test. So it is technically your step 0 that if you don't have the equations and you just have a paragraph of information, the first thing you need to do is create the two equations, but we're not really going to worry about that right now. The other thing I'm going to do slightly differently in this video is I'm going to write out the steps, but I'm not going to do a problem like alongside, like where I have the words over here and a little problem over there. We're just going to write out the steps, and then after that we'll do two practice problems with just two pairs of equations, and that's it. So like one question with a pair of equations, a second question that's built the same way, and that'll be it. So step 1, once you've got your equations, or assuming you've been given your equations, is choose one equation. Choose one equation and isolate one of the variables. Okay, so choose one equation and isolate one of the variables. So that means if I've given you two equations and they're both just a mishmash of x's and y's and numbers and things being multiplied together, and it's just mayhem, but you've got two equations for it, just choose one of the equations, completely ignore the other one for now, and transform it into y equals something something something, or x equals something something something. Now, because you have two variables, it's entirely possible that when you're solving one of those equations, you'll get something like y on the left side by itself, but then you'll have numbers and x's on the right side. That's okay. So as long as, so if you're dealing with x's, y's, and some numbers, some constants, if you've got y on one side and just terms with x's or terms with numbers or both, x's and numbers, on the other side, that's fine. The part that's not fine would be having y's mixed up on both sides and not really having anything sort of isolated by itself. So what you would want is to make sure that you've got one of the variables by itself on one side, and it doesn't matter if the other variable happens to be on the other side. Some of the equations will just work that way, that you'll end up with the other variable mixed in with some numbers on the other side. All that's important is that you make sure you don't have both variables mixed together on this side, and you don't have any other numbers or anything else attached to this. So you could have y equals something something that's involving x's, or you could have x equals something something, and over on that side you're allowed to have numbers. You could have y, you could have, you could have anything you want over on that side, as long as it's not more x's on that side, right? Because if you have more x's on the right side, you haven't isolated x. Isolate means to get that variable, in this case, by itself. So if you're isolating y, that means you want y to be all by itself on one side of the equal sign and everything else to be on the other side of the equal sign. So that's what it means to isolate. So you can just think about the meaning of the word if you get stuck on, have I properly isolated one of the variables or not? Or just think about what it means for something to be isolated. Is it completely on its own by itself? All right, so assuming you've gone ahead and done that, once you've finished isolating for one of the variables in one of the two equations, you can now take that result. So with the one I just had, I'm not going to do like a full problem with it. I haven't worked out that many for right now, and I want to make sure the numbers come out to be something nice. So if you have something like y equals x plus 4, and your other equation is just a mess of x's and y's and numbers. You've got 21x plus 33y plus 56 equals x plus y plus 10. So something just, you've got lots of terms in there. There's x's and y's and numbers on both sides, and it's a huge mess. All you have to do is anywhere you see a y in the other equation, you're going to sub in this relationship, because we know that if something is equal to y, it's also equal to, in this case, x plus 4. So if you had 21y sitting somewhere in the other equation, then you could rewrite that as 21 times, and then in brackets, x plus 4. So if your other equation was 21y is equal to something, like 63 or something, let's say. So if you've got 21y is equal to 63, then you could replace, there'd probably be more to it, but if you've got 21y is equal to 63, you can replace this y with x plus 4. And then if you had other x's in the problem, so if you had more x's over there and more x's over here, then you would be rewriting the problem so that you don't have two variables in that equation anymore. You would only be left with just x's or just y's, depending on how you've isolated your first equation. If you isolate for y in the first equation, then when you sub that result into the other equation, you'll be left with only x's, so only the other variable. Similarly, if you isolate x in the first equation, then when you sub it into the other one, you'll only be left with y's, or, numbers. Okay, so hopefully that makes sense. Let me put that in words. So sub that result. So sub the result from step 1, basically. So sub that result, in brackets I'll put step 1, into the other equation. Okay, so sub that result from step 1. Once you've isolated for one of the variables, you take that result, you chuck it into the other equation so that you've turned that second equation from, instead of being an equation with two variables, it's just an equation of one variable. And if you've got one equation made up with only one variable and some numbers, you can solve it. You don't need any other information to figure out what that variable must be equal to. It's just a matter of isolating that variable now. So once you've subbed it into that second equation and you've just got, let's say, a whole bunch of x's kicking about and there are no y's anymore, then you can just go ahead and solve for one of the variables, right? If you've just got, after all of this work in steps 1 and 2, if you're just left with, 21x plus 84 equals 119, then you can go ahead and calculate what x must be equal to make that equation true, right? So you can solve for one of the variables, whichever variable you're dealing with in that second equation. So solve for one of the variables in I'll say in the second equation, but I'll put quotation marks around that because you don't have to isolate the first equation that shows up on the paper. You can isolate, like in step 1, the one that you're isolating one of the variables, you can do that to either equation. It doesn't have to be the first one. It can be the second one if you like. Sometimes it'll be the first one, but so you can solve for whichever variable you're left with. Once you've plugged the result from one of the equations into the other equation, it's that second equation that you're dealing with that you end up solving. All right, so it doesn't matter which way they're listed on the page. It's just you're going to end up dealing with one of the equations first, and then you're going to deal with a different equation, and it's that second equation, that different equation, that you're trying to solve down here in step 3. Okay? So hopefully that makes a little bit of sense. I hope I'm not confusing you too much. And then the final step after that, I'm going to squeeze it in down here, step 4, is solve for the second variable. So solve for the remaining variable, maybe I'll say. Solve for the remaining variable. Alright, my apologies for the somewhat messy writing down there. It's just a bit uncomfortable to reach down to that corner of the whiteboard, but it says solve for the remaining variable down there. So step 4 is to solve for, it doesn't have to be, I was going to say solve for the second variable, but again, if you're dealing with x and y, you don't have to solve for x first because it shows up first in the alphabet or anything like that, or because it shows up first in the problem maybe. You can solve for whichever one looks easier first, and then solve for the other one after. It could be x first, could be y second. If you guys ever pursue like a university program that involves a lot of math, then eventually you'll stop using letters that you recognize. You'll start using things like Greek letters, and if you don't know your Greek alphabet, it doesn't really matter which one comes first or second, right? If you're dealing with symbols that you can barely pronounce the names of, then it doesn't really matter which one shows up first alphabetically. So the order of the variables in, the way they're used in language doesn't matter at all. If you've got x's and y's, there's nothing in the problem, unless I've said it explicitly in a sentence, there's nothing that's pushing you that you must solve for x first. You're more than welcome to solve for y first if it looks easier. Some people like to do the easy step first, so if it looks easier to solve for y, they'll do that. Some people prefer to do the hard stuff first to get it out of the way so that the rest of the problem is easy. So there isn't necessarily a right way to do it in that regard. You can do the hard stuff first, the easy stuff later. You can solve for x first, solve for y first, equation 1, equation 2. You have so many choices at every step of the solution. The only thing you don't really have a choice with is sort of this broad process. So when you're choosing an equation to isolate one of the variables, you're choosing equation 1 or 2, and you're isolating for x or y. Then when you move down to step 2, it depends on the choices you made in step 1, right? If you solved equation 1 for x, so you got x by itself in equation 1, then in question 2, you're going to be dealing with y's and equation 2. So basically all the stuff that you didn't use in question 1 is what you'll be dealing with in question 2 or in step 2. So yeah, whatever you choose in step 1, you'll be dealing with the other stuff in step 2. And not so much dealing with it in step 2, you'll actually be dealing with it down here in step 3. In step 2, you're just subbing in one of the results from the beginning into the other equation, and then in step 3 you're actually doing the math with it. That's where you're actually solving for one of the variables. So if up here in step 1 you decided to use equation 1 and solve for x, then down here in step 3 you're going to be using equation 2 and solving for y. And then you plug that result, I didn't actually write that up here, but you plug that result back into the first equation to solve for that first variable. So if you were dealing with equation 1 and x up here, then when you get down to this step, you're going to be dealing with equation 2 and y, and that's going to actually give you a number for y. So you'll get something like y equals 3 down here in step 3, and then you take that y equals 3, you plug it back into the other equation. So if the other equation was something like, let's say, x equals y plus 4, then, so first you solve for x, that would have been your step 1. Then you sub that result into whatever your second equation is. That's your step 2. Whoops, I messed up my star. That's your step 2. Then in step 3, you get something like y equals 3 as your result down here in step 3. I have messed up my star again. What am I doing? So then you get an answer like y equals 3 down here in step 3. Now you sub that back into the first equation, and then you can solve for x. So then you would replace this y with a 3. You would get x equals 3 plus 4, which equals 7. And then you would have a numerical answer for each of your two variables, and you'd be done the problem. Alright, so hopefully that process in general makes sense. I'm going to erase this now, and we'll do two practice problems. So both of them are going to be two equations, two variables. That's the other thing you got to remember, is that if you've got two equations that have been, well, if you've got two variables that you need to solve, you need to have at least two equations to work with. If you have more than two variables, then you're going to still need the same number of equations to actually solve the problem. So if you've got 4 variables, you need 4 equations. If you've got 10 variables, 10 equations. Now obviously we're not going to touch anything quite like that in here. Even I don't tend to do math questions like that at university with like 10 variables or anything like that. But that's just a rule of thumb that you should know. So if you're dealing with 3 variables, like could be x, y, z, or a, b, c, something like that, alpha, beta, theta, if you're doing it with Greek letters, then you would need, if you're working with 3 variables, then you would need 3 equations in order to be able to get an answer for all 3 of them. All right, so with that out of the way, that's just a little bit of a sort of a side note. Let's get back to working with 2 variables. So question 1, I'm numbering the question with Roman numerals because I'm gonna label equations 1 and 2 with the numbers that we're familiar with. So equation 1 is 13y, yes, 13y plus x equals y plus 30. Okay, so the one thing that I didn't mention when you're setting up the problem, you don't really have to do it, but it's a little bit neater for anybody who's trying to make sense of your solution, or if you're trying to understand it when you go back to it later, is number the equations, label the equations. You can call them 1 and 2. You could do it with Roman numerals, so like I and II. You could do A and B. You could do, I don't know, you could do like a happy face and a sad face. I don't care if it's numbers or letters or whatever. Just give them a little bit of a label, give them a name. Don't call them like names of people, because then it just gets confusing. Don't call it like Bob and Washington or anything like that. Give them a name, give them like a 1 and 2 or A and B or something like that. Just so that you can sort of explain what you're doing with which equation as you're going through the math, because otherwise it's just a mess of numbers down here if you don't explain what you're doing. So equation 1, we've got 13y plus x equals y plus 30, and then equation 2 is going to be y equals x over 3, or x divided by 3. Alright, so now we want to solve for x and y. Now in this one, if I look at equation 1 looks more complicated, so I'm going to go down to equation 2, and we're going to work with equation 2. Now here we've already solved for y, like the way we've been given the equation, it's already got y by itself. So if you want to just work with y by itself, you're more than welcome to. However, if I've got y by itself over here, that means y is equal to x over 3. So that means that if I take this information from equation 2 and sub it into equation 1, then anywhere I see a y, I need to replace it with x over 3. So don't write this down, but this is what it would look like. It would look like 13 times x over 3 plus x equals x over 3 plus 30. There's nothing wrong with that. If that's how you want to go about solving the problem, you absolutely can. This used to be a y, right? And this used to be a y. No problems there. I've substituted in this information into equation 1 and it gave me that. However, I don't like it that way. I don't want to be dealing with 13 times x divided by 3. 13 is a prime number. It's not going to be divided nicely by 3. We're going to end up with some weird fractions or decimals. It's not going to be a fun time. So the way I'm going to do it is, even though equation 2 is already solved for y, I'm going to adjust it and solve it for x. So this is just, I'm going to rewrite the same equation over there, but in a different form. So if I wanted to solve this for x, well, right now I'm dealing with y equals x over 3. I don't want it to be x divided by 3, I want it to just be x. So to do that, I'm going to multiply this side by 3. That'll make these 3's disappear. But if I multiply this side by 3, I also need to multiply this side by 3, which leaves me with 3y on the left side equals x on the right side. So that means I could rewrite equation 2 as x is equal to 3y. Note I've switched the order from the left side and the right side. The right side over here is the left side over there. That you're allowed to do. Just don't change anything else when you do that. You're allowed to flip that order. You don't need to change any minus signs or anything like that if you're just flipping the equation around from this to that. All right, so now this is the new equation 2, right? This is the new equation 2 that we're dealing with. And so now I'm going to say, when I'm explaining what I'm doing, I'm going to say subbing equation 2, so 2 with that circle around it, subbing equation 2 into equation 1. If I'm subbing equation 2 into equation 1, that means I'm subbing this fact into this big equation out here. So what that gives me is, anywhere I see an x, I need to replace it with 3y that we got from over here. So that means this first term, 13y, it's not going to change. So we've got 13y plus, and then here's our x, so we're going to replace that with 3y equals, and then on this side we don't have any x's, so that's fine, we can just write y plus 30. So now you can see a little bit of what I was saying when I was sort of rambling on a few minutes ago about when you have choices about what to solve. So what I've gone and done here is I've taken equation 2 and I solved for x. So when I sub that information in, I'm dealing with equation 1 mostly, and now I'm solving for y. So whatever you start out with at the beginning, if you choose equation 2, solve for x, then ultimately you're going to end up dealing with equation 1 with y's. So whichever equation you choose at the start, you're going to end up working with the other equation first, like actually solving it for something, and whichever variable you solve for first over here, you're going to actually get a number for the other variable first. Okay, so it's a little bit backwards that way. If you thought, oh, you know, I'm going to solve equation 2 first, and I'm going to get the number for x before I get the number for anything else, that's not how it works. If you choose equation 2 and you isolate x, that means that you're going to end up working with equation 1 and solving for y. All right, so let's go ahead and do that. We've got equation 1, we've got y's everywhere. Let's solve for it now. So just like working with one variable, we can combine these together. It's like 13 apples plus 3 apples. So that would be 16 apples, or 16y, on this side. Maybe we should choose a word that starts with y, like yams or something. So 16 yams on the left side, and then we've got y plus 30 on the right side. All right, but I don't want y's on both sides. I want all the terms with variables on this side and all the numbers on that side. So I'm going to pull this y over to the left side. So basically I'm subtracting y from both sides. So if I subtract y from that side, this y disappears. If I subtract y from this side, that's 16 yams minus 1 yam. That's going to leave me with 15 y equals just 30 on that side. So now I've got terms with variables on the left side and terms with just numbers, terms without variables on the right side with that 30 over there. Now I can solve for y by dividing by 15, right? I don't want 15y, I just want y. So I divide this side by 15, but if I'm dividing this side by 15, I've got to divide that side by 15. These 15s will cancel each other out. So 15 divided by 15 is 1, which is going to leave me with just the y left over, equals 30 divided by 15 is 2. So then from that we get that y is equal to 2. All right, and now we've ended up using equation 1 and solving for y. Now we're going to take this result, y equals 2, we're going to sub it back into equation 2 and solve for x. So we got this equation over here, the one that we put in a bubble. I'm going to box this section off. We've got x is equal to 3y. So if you wanted to actually, let me move this down ever so slightly. So x is equal to 3y is what we got back at the beginning. If you wanted to make a statement to explain your answer, you could say sub y equals 2, because that's the answer that we got, into equation 2. That's what we're doing now. If you wanted to explain it with words, is you're subbing in that answer, sub in y equals 2 into equation 2. And this is our equation 2, or at least our new equation 2, if you will. Right? So we're subbing y equals 2 into this equation. So this is the original equation that we started with, but we know that y is equal to 2, so it's going to be x is equal to, instead of 3 times y, it'll be 3 times 2, and 3 times 2 is equal to 6. So then you get that x is equal to 6. Okay, so at this point you should be done. You've got an answer for y, you've got an answer for x. All that's really left to do is check your answer. So I'm going to leave that for you guys to do. Double check if you plug in y equals 2 up here and y equals 2 over there and x equals 6 over here. Just check that the left side and the right side, when you do that multiplication and addition, that they come out to equal the same thing. Or you could check it down here as well, that if y is equal to 2, x should be equal to 6. That one's much easier to check just off the top of your head. But just double check your answer, make sure it makes sense with the equations that you've been given. It's a really good way to make sure that you're on the right track with your solution. And of course, if you're at the very end of the problem, then you don't have to worry about anything after that. But again, if you're dealing with like a university math program, a few years down the road, then this might not be the end of the problem. This might be the start of the problem. And then you have to use these results in other scenarios and in later parts of the question. Like some of my physics exams back in first year, they would have like a question 1 part A, and then they would have part B, which depended on the answer that you got in part A. And then they'd have part C, which depended on the answer you got in part B. And so it would just, you'd have 5 or 6 parts of the question, but part F depended on part E, which depended on part D, which depended on part C. So if you mess up something like this back near the beginning, you're losing marks for the rest of the question, which is kind of not good. So yeah, so just double check your answer. You've been given the tools to double check your answer, so make use of it as long as you've got the time for it. But yeah, so that's it for this problem. I'm going to get rid of this now. We'll just quickly zip through one more, and then I'll let you guys go. So I'm going to leave the labels for equation 1 and 2 here, and we're just going to erase the equations and put some new ones. And it's also question number 2 now. So question number 2, this can go, and this can go, and that can go. All right, we'll do this one a little bit faster. I'm not going to point out as many small things. I'm just going to go through the problem and tell you what I'm doing as I go. So for this one, question 2, equation 1, we've got 4x plus 2y is equal to 8y, sorry. 4x plus 2y is equal to 8y plus 4. All right? And equation 2 is going to be y plus x equals 4. Okay? Now, how do I choose which equation to solve? Now, for me, equation 2 is a lot smaller, so I might as well solve this one first. So I'm gonna mess around with equation 2 until I've got x is equal to something something or y is equal to something something. Now, x and y are both on the same side of the equation. There's one number on the other side. Neither of these is multiplied by anything else. So it's not more work to solve for x or more work to solve for y, but I still need to choose one. You might not care and you can just go with one or the other, but I look at equation 1 and I see I've got a y in 2 spots over here, but I've just got an x in 1 spot. So if I solve for x, I only need to make that substitution of x equals something in 1 spot right here instead of in 2 spots over there. The more places I need to sub in new information, the more chances I have of making a mistake. I'm really prone to making those mistakes, which is why I try to look for these kinds of things. But if you're not the type of person who's going to make mistakes with that kind of stuff, then don't really worry about it. So for me, I see that if I solve for x down here in equation 2, I only need to sub it in one place up in equation 1. So I'm going to solve for x over here in equation 2. And to do that, I've got y plus x equals 4. I don't want this y being added on to the x, so I'm subtracting y from this side, but that means I have to subtract y from that side. So that means this y and that y will disappear. I'll be left with x is equal to, well, that's a terrible 4. X is equal to 4 minus y. So we get x is equal to 4 minus y over there. Okay, so this is my new equation 2, so I'm going to put that in a bubble. All right, now I'm going to get rid of this, and we're going to sub equation 2 into equation 1. So we're going to sub this new equation 2 over here into equation 1. So basically, anywhere I see an x, I'm going to replace it with 4 minus y. Now I only have x in 1 spot up here, that's why I dealt with x down here. So let's go ahead and do that. So 4, it's supposed to be 4 times x, so I'll put parentheses here that will put in what we need over there, and that'll be multiplied to 4. So x is now 4 minus y, so that's what's going to go in here. 4 times 4 minus y. All right. Plus 2y equals 8y plus 4. Okay? So now I can go ahead and I can do the multiplication here with the distributive property, which we've talked about before, I believe. So I'll start off with 4 times 4, that's 16. And then 4 times y is going to be 4y. There's a minus sign in the middle here, so there's going to be a minus sign in the middle here. If you guys don't remember how to do distributive property, let me know as soon as possible. But this is basically the way it works. You just multiply whatever's out here by whatever you see on the inside individually. So we got our 4 times 4 is 16, 4 times y is 4y, and then that minus sign in the middle over there goes down over there. So we've got 16 minus 4y, that's just dealing with this. Now we still have that plus 2y kicking about over there. And then on the other side, we've got 8y plus 4. So now I can do this math with my y's over here. I've got negative 4y, remember, because of this minus sign, it's really negative 4y, not just 4y. negative 4y plus 2y. So that would be like saying it's negative 4 degrees, like Celsius outside, and then it gets 2 degrees warmer. So it's not going to be positive 2, it's still going to be a negative number. If it's negative 4 degrees outside, and then it gets 2 degrees warmer, it'll be negative 2 degrees at the end of that. So the 16 stays the same. I'm going to be left with minus 2y over here equals 8y plus 4. Now I want all the y's on one side and all the numbers on the other. I don't want a negative term here, so I'm going to take this 2y and throw it over to that side so that it becomes positive when it goes over there. And then this 4 I'm going to have to bring over to the left side, and it's going to become negative when I bring it over here. So right now it's plus 4 on the right side. In a second it's going to be minus 4 on the left side. And then similarly this 2y, right now it's minus 2y on the left side. It's going to end up being plus 2y on the right side. So writing that out, we're going to get 16 minus 4 equals 8y plus 2. Alright, so we've got 8y plus 2y. Excuse me, I left a y out there. So we've got 16 minus 4. Let me write that a little bit bigger. So we've got 16 minus 4 is equal to 8y plus 2y. Alright? So now 16 minus 4, that's going to give us 12, is equal to 8y plus 2y, that's 10y. And then you can solve for y by dividing both sides by 10. I'm going to have to move that up over here. So if I divide both sides by 10, 12 divided by 10, and 10y divided by 10. So 10y divided by 10, that's going to leave me with just y on the right side. And then on the left side, 12 divided by 10 is going to be 1.2 if you do the division. So 12 divided by 10 is going to give me 1.2. So that's not the nicest number to work with, but we don't have to worry about it too much. And now that's it for y. We've got a number as an answer for y. So now we can sub in y equals 1.2 into equation 2, right? Or into the new equation 2 that we created over there. So we know x is equal to 4 minus y, but y is equal to 1.2. So instead of writing 4 minus y, I'm going to write 4 minus 1.2, and that should leave me with x is equal to 2.8. And so that should be your final answer for this one. Y is equal to 1.2 and x is equal to 2.8. And then you could go ahead and check your answer by plugging in those values for x and y up here in equation 1 and equation 2 and making sure that you've got the right answer for both of those. So I hope all of that made sense. The next video is, I think, going to still just be practice problems, so we're still going to see a little bit more of this, and then after that there'll be a brief test review of things that you should be able to do for your upcoming test, and then I will send you guys that test in the coming days. Yeah, I don't think there are any more sort of housekeeping items that I need to mention right now, so if I think of anything, I'll mention it in the next video. As always, get in touch with me if you have any questions. Otherwise, I will see you next time. Have a good one.